Hey again, guys. So in this video I want to show you how to determine if two different expressions or seemingly different expressions are equivalent or not. Okay, so we're going to consider in this particular video our f of x equals 5 times x squared plus 3x minus 2 minus 2x plus 4 all squared, and g of x equals x squared minus x minus 26 equivalent. So I got two different expressions, or I guess in this case two different functions, and I want to determine if they're equivalent or not. So let's start by considering ways that maybe we could determine if they're equivalent. So let's see. Maybe we could potentially figure if they're equivalent by graphing. So actually, yeah, we could. So this is an okay method. So the idea is, if you wanted to, you could graph both of these functions, and if it gave you exactly the same graph, that would be proof that they are equivalent functions. Okay, so how about if we tried substituting x values? So maybe that would work. Well, the problem is, for two functions to be equivalent, we need to know that every single x value that we could possibly substitute into either of them will give us exactly the same y value. Now, since we can't substitute all the x values, since, for these particular equations, for example, the domain is going to be an infinite number of values, right? We can't substitute them all, right? That means we can't check every point, and really all that's necessary for them to be not equivalent is for one of the x values to not give us the same result in both equations. So unfortunately, substituting x values will not be able to prove that they are equivalent, but what substituting x values can do actually is it's actually a way that you could check to see if two expressions are not equivalent. So for example, if you know that these two functions would give you different results when you substituted in x equals 5, you could substitute in x equals 5, and since you found an x value where they give you two different y values, that's evidence that they are not equivalent. Or it's not evidence, it's actually proof that they're not equivalent. Okay? So all you need is one x value to prove that they're not equivalent, and that's where substituting x values could come in handy. So let's think of another way. So maybe we could try simplifying. So is simplifying going to work? And actually we can. So we can simplify the equations and see if they give us exactly the same thing. So we're going to try doing that here. So I want you to notice that f of x looks like it's something that could be simplified or expanded and all that. It doesn't really look like we do much with g of x. I mean, we could factor it and so on, but that's really the opposite of simplifying in this case. We want to kind of leave it in fully expanded form. So what we're going to do is we're going to start with f of x, and we're going to expand it out and simplify, collect like terms, and so on, and see what we get. So let's write down f of x. So f of x equals 5 times x squared plus 3x minus 2 minus 2x plus 4 squared. So what I'm going to do is I'm going to expand the 5 into the first set of brackets, into that first trinomial. And then we're going to want to multiply 2x plus 4 times itself, because that's what 2x plus 4 squared means. Let's write that down. That gives us 5x squared plus 15x minus 10 for the first set of brackets, and then I'm going to write 2x plus 4 times 2x plus 4 since we're squaring it. Now I'm going to expand out 2x plus 4 times itself. So we're left with 5x squared plus 15x minus 10 minus, and in brackets we'll have 4x squared plus 8x plus 8x plus 16. So that's what we get when we expand out 2x plus 4 times itself. Okay, and now I can start collecting like terms. So 5x squared minus 4x squared, for example, is going to give us 1x squared, 15x minus 8x minus 8x, right? Because we have these two 8x's here, right? So 15x minus 8x is going to give us negative 1x, or just negative x. And then we have negative 10 minus positive 16, which gives us negative 26. So f of x simplifies to x squared minus x minus 26. And you're going to notice that that is actually the same expression as g of x. So since we can simplify f of x to get the same answer as g of x, we can say that f of x and g of x are equivalent. So here I just went through all the ways that you could potentially show that two expressions are equivalent, or perhaps even not equivalent. All right, take care, guys.